Hey folks, my name is Ravi Sahita and I work at Rivos. Today I'll be describing our poster on confidential VM extension for RISC-V platforms. So what you see on the figure is a canonical privilege modes for the RISC-V architecture. So RISC-V is an open standard ISA, and on the vertical axis you can sort of see the privilege levels that RISC-V supports, which includes the user mode, a supervisor mode, and a machine mode. And in addition to that, RISC-V also supports a hypervisor extension, which is a recently ratified extension to the PrivISA, and that allows hardware virtual machines to be hosted by the supervisor extending its control through a hypervisor extension, which is shown as the HS mode, which allows guest operating systems to essentially run in a virtual user and virtual supervisor privilege mode of operation. So we leverage the hypervisor extension in RISC-V along with some other extensions that we have been working on ratifying in the community in RISC-V International, which includes the IOMMU and the advanced interrupt architecture. Furthermore, as you can see in the horizontal axis, we have been working on a privileged ISA extension called supervisor domains, which essentially extends the isolation architecture on RISC-V to allow more than one supervisor domain to be instantiated on a RISC-V based platform. So those set of extensions together are leveraged to essentially build a confidential VM extension, which essentially also adds beyond the ISA a set of non-ISA extensions or ABI interfaces to certain critical security components that are introduced as part of the CoVE architecture. So as part of the CoVE architecture, we essentially introduce the notion of a TE security manager, which essentially forms one of the core parts of the TCB for the confidential VMs that are shown in this figure, along with obviously the TCB consisting of the hardware and any attestation elements such as the hardware root of trust and SOC elements such as the IOMMU and any memory controller interfaces, etc. So the CoVE ABI, the work done in the task group in RISC-V is split into two parts for the ABI: the baseline CoVE ABI and an extension called the CoVE IO ABI. The CoVE IO ABI essentially extends the scope of the TVM or the CoVE VM that's run in the CoVE architecture to essentially also be able to admit device functions that may be behind a PCIe root bridge with an IOMMU essentially acting as the IO side memory management unit. These ABIs are also built to be compatible with some of the existing Linux KVM interfaces that are used for other architectures for confidential VMs. So we think that this will dovetail pretty nicely with those other extensions. Furthermore, there are a set of security recommendations that the CoVE architecture makes, and a lot of these are documented in the RISC-V security model, which is a self-standing specification. And essentially, CoVE recommends using a transparent open source model of building these TCB elements, be it the silicon or the software. And some good examples of this are the open source TSM that Rivos has implemented in Rust called Salus. And another good example of an open source silicon root of trust is the OpenTitan project. The other interesting point I wanted to mention here is a lot of the CoVE interfaces follow standard industry interfaces, be it for cryptography usage within CoVE or for some of the device attestation, device authentication, and as well as enforcing the TE state machine on the device. So these are protocols like the SPDM protocol for device authentication or the TDISP protocol from that is being developed as part of PCIe and CXL to enforce the state machine on a TE compatible device. So that was a quick summary of the CoVE extension. I invite all of you to sort of participate in the task group in RISC-V and help develop these interfaces as they go towards ratification. Thank you very much.